So when you use a smartphone, you use social media, you use internet banking, most people would assume that you're using satellite communications. But actually more than 99% of all digital data traffic is carried by a network of about 1.4 million kilometres of cables that cross the global ocean. So the cloud is very much underneath the sea, it's not in the sky. From a UK perspective, we have many submarine cables that connect us, which means that if one of those cables or a couple of those cables are damaged, that we can rely on other cable routes to reroute the data traffic. In the case of many small island developing states, particularly in the South Pacific, there are very few cables. An island nation such as the Kingdom of Tonga currently only have one cable which connects them to the rest of the international network. This means that there's a greater vulnerability for those nations, and particularly because those sorts of locations are often in areas that have active earthquakes, active volcanoes.
So the Tonga eruption is a really significant event. Basically, the entire nation was cut off from the internet during sort of a time pretty critical for disaster response. The international cable was damaged along 89 kilometres of length and the domestic cable along 105. So the repair effort was really, really difficult actually for these cables.
You may be aware that Tonga, about almost 50% of its GDP is from families abroad. Nobody could make any contact with anybody for at least 3-4 days. So we went from having very good connectivity to less than about 1%.
We managed to get a research grant funded very quickly through the NERC Agency programme, which allowed us to work with some of our partners in New Zealand to get a research vessel on site really soon after the event. We already had a map of the seafloor before the eruption happened, which meant when we mapped it again, we could see how it had changed. And those two maps meant that we could understand the impact this eruption had had on the seafloor in a way that has never been possible for a previous eruption.
They were the ones that were able to get funding to enable the newer research centre in New Zealand to be able to send a vessel out to come and do the survey on the volcano, and through which we made a request to also see if they could survey our cable paths as well, so that we had an idea of what was happening to our cable, so that we could inform the cable repair ship coming in as to the status of the cable paths.
So NERC funding's been really important for a number of different reasons. It's underpinned a whole range of international collaborations. This has allowed us to broaden the reach of the research. It's provided access to infrastructure. NERC funding's also allowed the development of world-class models, particularly looking at the impact of future climate change and how hazards may change. It's brought in engineers, it's brought in geologists, physical oceanographers, but it's also allowed us to have this bridge with industry and policymakers. And hopefully we've been able to close a bit of a loop there to then feed back information as we've analysed those data sets to help them learn from that, to make sure that future developments, future cable routes are future-proofed.